Catholic High Prelim paper for 2023, paper 1. Question 1. Which of the following is 567,030 in numerals? 567,000. So it will be 3. Okay, 567,030. What is the value of 3 divided by 600? So 3 divided by 600 can otherwise be written as 3 divided by 6 divided by 100. Or you can divide by 100 first. Okay, 3 divided by 6 is actually 0.5. Because 3 over 6 is half. Half is 0.5. Then divide by 100. Now, if you want to divide by 100, the decimal point will shift to the left 2 times. So you end up with 0.005. So option 4. What is the possible length of a badminton court in a school? Okay, let's eliminate what are the answers that are likely to be wrong. 13.4 cm. 13 cm, a ruler is about 15 cm, right? So no, definitely not. 13.4 meters, probably. 13.4 meters, okay? Let's look at 3 first. 134 cm. 134 cm is 1 meter plus. 1 meter plus, that's not, that is probably the height of like a lower primary kid, right? Or a small kid. Okay, so no, not that. 134 meters. If you run a race, 100 meters is like from one end of the track to the other. So it is definitely not that long. If you want to play a badminton court, it can't be that long, right? So answer is option 2, 13.4 meters. Which of the following shows 25% of the figure shaded? 25% is a quarter. These 2 triangles can be combined and it will form 1 square. 1 square out of the whole thing. So there are 4 squares. So it's option 1. Not option 2, because if you were to combine all in 1 line, it will take up 1 line out of 5. So that's 1/5. So no. This one definitely not, because they're not cut into equal parts. Then this is 1 out of 5 as well. So 25% is 1/4, option 1. Question 5, in a number line, what is the value represented by x? Okay, so we have 3.9 to 4.0. That is an increment of 0.1. 0.1, there are 1, 2, 3, 4, 5 intervals in between. So if I take 0.1 divided by 5, 0.1 is the same as 0.10. And if I divide by 5, I will get 0.02. So keep adding. 1, 2, 3. 3 times of 0.02 is 0.06. So this has to be 4.06. Option 2. Question 6. A cut along a diameter of a circular paper will obtain 2 equal pieces. How many such cuts along the diameter must be made to obtain 16 smaller pieces of equal size? Now let's try and find what is the number of pieces we get when we add 1 more cut. Okay, so if I were, okay, you want equal sizes. First, let's cut it this way, maybe. Then you get 4 pieces, right? So 2 cuts. 4 pieces. Then 3 cards. Okay, it's not equal, but just to show you how many pieces. If you have 3 cards, you have 6 pieces. Then if you have 4 cards, and you count, you have 8 pieces. So as you can see, the number of cards to number of pieces is double. Okay, it's all times 2. So if you want 16 pieces, you'll take 16 divided by 2, which is 8 cards. Okay, question 7. ABCD are points on a square grid. Which point when joined to y forms a line that is perpendicular to xy? Now, if you want to find a line that is perpendicular to xy, it needs to cut the grid across in the same way. So let's say this line is cutting across 3 squares. We need to find another line that is cutting across 3 squares. So let's say I join y to c, right? This is not perpendicular because it's cutting only across 2 squares. Okay? Not to b because it's too far away. It's cutting across 1 square, 1 square, 1 square. Okay, when I say cut across 3 squares, I mean like nicely sitting in a corner. The next time it sits nicely in a corner is 3 squares away. But if I were to connect to B, it sits nicely in a corner just 1 square away. Okay, it just cuts across diagonally like that. But no, it must cut across 3 squares, then it sits nicely in a corner. So it's actually y to d. Use a ruler. So if you can see y, if you connect to d, at point D is when it sits nicely in the corner of the square. Okay, so YD cuts across 3 square. The answer is D. For A, if you connect it, right, it will only sit nicely in a corner of the square 4 squares away. Okay, question 8. In a figure, Q, R, and ST are straight lines. Let's highlight. Okay, with this, you have a vertically opposite angle. So 106 and 27 is actually m plus 90. So let's add 106 plus 27. Then you minus off 90. Because this whole thing here is 133. So answer 3. Bar graph shows the number of cakes baked by a bakery over 4 months. Number of cakes, the number is not shown on the graph. Okay, just show you like visually which one looks like the most and the least and so on. So which of the following table represents the bar graph above? June as the greatest, so look for the one that shows June as the greatest. Now, actually everything shows June as the greatest. Okay, how about the least? The least is May. If you compare, May is the least, May is the least. Oh, okay, everyone, all these shows May is the least. Okay, now maybe let's count the units, okay? So let's say every one gap is 1 unit. So this is 5 units, this is 10 units. 15 and 20. So April is 8 units. May is 7. This is 19 and July is 9 units. Okay, look for numbers that are proportional to these values. So actually it's option 1 now. Okay, so 8 is 80, 7 is 70, 19 is 190, 9 is 90. So it is proportionally the same, whereas the rest are not. Okay, next one. Question 10, there's an error with this question. There's actually no answer for this question. None of the nets, or rather all of the nets shows a net of a cuboid. No, wait. Okay, sorry. Option 2 is the answer because, okay, sorry. Let's go through one by one. This is the top, right? This is the bottom. So you have the 4 sides. Okay, so then this is the top, this is the bottom. Now these two will overlap, right? So actually, okay, option 2 is not the net of the cuboid. Oh, sorry. Okay, I know what's wrong with this question. If you look at option 3, right? These will actually overlap. Sorry, this one and this one will actually overlap. So option 2 is not a net of a cuboid. Option 3 is also not a net of a cuboid. And this one is, this is the top, this is the bottom, and then you have the sides. So there's actually 2 answers here. Yeah, so okay, so that's the error in this question. 2 answers. No one solution now, okay? Question 11, arrange these from largest to the smallest. So I will change the mixed number to liters and ml so that it's easier to compare. This is 2 liters and 3/5 liters is actually 600 over 1000 liters. So this is actually 600 ml. Then this is 2 liters, 350 ml. Largest, the one with 600 ml. So 2 and 3/5 is the largest, not this, not this. Next followed by this 350. So 2.35 next. So option 1. Question 12. Walter packed 4/5 kg of flour into as many bags of 1/4 kg as possible and had some flour left. What is the mass of the flour left? Now, 4/5 kg, if you want to pack it into bags of 1/4 kg, you have to divide, right, to find how many bags. Okay, let's do that. 4/5 divided by 1/4. Change, flip. So keep the first fraction, change the sign to times, flip. So 4 over 1. 16 over 5, which is 3 wholes and 1/5. Now, what we're interested in is not the number of bags, but like how much of the flour is left. Now, 3 and 1/5 means that you can get maximum of 3 bags, and then you're left with 1/5 of a bag. What is 1/5 of a bag? 1/5 of a bag is not 1/5 kg. Because 1 bag is this much. So to find 1/5 of a bag, we take 1/5 times 1 bag. And we'll get 1 over 20 kg. Okay, so this is the amount left, not 1/5. 1/5 is the proportion left. Jean had some tickets to sell after selling 56 in the morning and 4/7 of the remainder in the afternoon. She was left with 1/5 of the tickets. How many tickets were sold altogether? Okay. Model. 56 in the morning. 4/7 of the remainder. Let's cut it. Afternoon. And she's left with 1/5 of the tickets. 1, 2, 3, 4, 5, 6. Okay. This is, oops. There were too many units. Okay, you should have 3 units left, and this is actually 1/5 of the total. Now, 1/5 of the total is 3 units, right? So 1/5, I will change it to 3 units. So 3 in the numerator. So 3 over 15. What this means is that the amount left is 3 units. The amount left is 3 units. 15 is actually the total. So to find 56, I will take 15 units minus of 7 units, which is 8 units, and 8 units is 56. So 1 unit is 7. How many were there? How many were sold all together? Now we're only looking for the amount sold. So it's actually 15 units minus this 3 units. Twelve units is what we're looking for. So 12 times 7, 84. So answer 2. Okay, question 14. After a 20% discount, the price of a t-shirt was $40. A first-time customer was given a further discount of $6. What was the total percentage discount given to a first-time customer for the t-shirt? Okay, percentage discount is discount over original times 100%. So there are 2 things we need. One is the discount, one is the original price. So if after 20% discount, it's at $40, right? Means that this $40 is actually 80%. Okay, so 2 things I need. One is the original price, one is the total amount of discount. So the discount is 20% first. So let's find 20%. So to do this, we divide by 4. $10. Now, that's not the only discount that a first-time customer is getting. So the total discount that a first-time customer can get is not just $10, but 10 plus 6. It's a further discount of $6. Okay, so I've already found the discount, which is $16. Then now let's find the original price. Original is discount plus the $40 that was paid. So basically 100%. So it's the 10 plus 40, or you can find 100%, which is 10 times 5. You will also get $50. Then using the formula, 16 over 50 times 100%. You can simplify this. This is 1. This is 2. So 16 times 2, 32%. Option 3. Question 15. In the figure, ABCD is a rectangle made up of 4 triangles. The ratio of the area of triangle ABF, this one here, to that of the rectangle is 1 to 9. Okay, let's write that down first. ABF to rectangle 1 to 9. Okay, then the ratio of the area of triangle AFE, this one, to the whole rectangle is 1 to 6. So AFE to rectangle is 1 to 6. Now, we need to find common base, which is the rectangle. So lowest common multiple is 18. This is 2. This is 3 to 18. ABF is 2 units. AFE is 3 units. Okay, so we need to identify the statements that are true. Statement A, ratio of ABF to AFE is 2 to 3. Yes, that is true. So A is definitely right. And we eliminate those that doesn't have A. So you're left with A or A and C. Then we know for sure B is false. But let's check anyway. ED is the base of a triangle EFD and its corresponding height is EF. No, not true, because ED and EF they are not perpendicular. So no. And statement C, the sum of the area of triangles ABF. Okay, wait. ABF, this triangle, and DFC. ABF and DFC is equal to the sum of AFE and EFD. So what they're saying basically is this triangle here is the same as these two combined. Is it true? Yes, it's true. Because this triangle, this big one, AFD, which is a combination of these two smaller triangles, is actually half of the whole rectangle. Okay, so these two triangles will take up the other half. So yes, it's true. So option 3. Okay, question 16. Round this number to the nearest tens. 43.558. Approximation sign. Tens place is over here, but you have to look at the next number. So 43.6. Because the next number is a 5, you're going to round it up. Okay, find a value of 1.58 times 70. You can times 10 first, then times 70. If you times 10 is 15.8. Sorry, times 10, then times 7. 15.8 times 7. You're working, make sure the decimal is in the same place. 35, 40, 0, bring up 4, 7, and this is 11. 110.6. Okay, find the value of 350 divided by 8. Whenever you have divide for fractions, keep, change, flip. Can apply this. So you keep the first fraction, change the sign, and flip the number. 18 is the same as 18 over 1. So when you flip, it's 1 over 18. Simplify, top and bottom. Divide by 3, divide by 3. Numerator times numerator, denominator times denominator. 1 over 30. Okay, question 19. Table shows the start and end time of 2 radio programs on the same day. So program B is 20 minutes shorter than program A. What time does program B end? Okay, let's find out what's program A's duration first. So for A, we're talking about 10:45 a.m. to 12:20 p.m. If you can do this straight, you can go ahead. Otherwise, you can split it to like 11 a.m. first, which is 15 minutes. Then you go to 12:20 p.m., which is 1 hour 20 minutes. So total time is 1 hour 35 minutes for program A. Now for program B, 20 minutes shorter. 1 hour 35 minutes minus 20 minutes. This is time duration, so you can minus 1 hour 15 minutes. So let's find 1 hour 15 minutes from 5:20 p.m. One hour later, 6:20, 15 minutes later, 6:35 p.m. So 6:35 p.m. Question 20. Figure is made up of 16 identical squares. There are 5 shaded squares, 1, 2, 3, 4, 5. In this figure, shade 3 more to form a symmetrical figure with AB as a line of symmetry. Okay, so line of symmetry is like the mirror line. Whatever you have on one side, you need to have exactly the same on the other side. So this one is already halved, okay. Now this one is the same as this square here, so you have to shade this one. All right, so then this one is the same as this one. So shade this. Then this one here is, okay, maybe you can count it this way. 1 square, 2 squares. So 1 square, 2 squares. So just shade the one in red. The blue lines are just me showing you. You don't need to draw that. Okay, question 21. I'm not able to show you here how to measure, but just use your ruler to measure this. Make sure you use your protractor to measure angle ABC. Read from the correct scale. Always start the scale from 0. So you should get about 9.4 cm and 125 degrees. Question 22. Hui Min folded 5p plus 2 paper cranes on Thursday. She folded p more paper cranes on Friday. How many did she fold altogether for the 2 days? Thursday, 5p plus 2. Friday, p more, so we have to take Thursday and plus p. So we'll get 6p plus 2. But you want all together, so let's add both days up. Add up all the p's, all those with p. 5p, 6p, that's 11p. 2 and 2, 4. So 11p plus 4. (23) This is the graph. This is the table showing the charges for a cleaning job. Mandy paid $145 for a cleaning job. How many hours of cleaning did she pay for? Now, for the first 2 hours, it has to be $35 per hour, just for the first 2 hours. Let's find out how much is that. So 35 for 2 hours will be $70. She paid $145, which is more than the $70. So we know for sure it's more than 2 hours. Okay, let's minus off 70 and see how much is left. $75. For every additional hour, it's the charges is $25. So like how many hours would that be? There's $75. So number of hours, number of additional hours. So we take this amount, divide by the amount every hour. You end up with 3 hours. Now remember, there is the first 2 hours. So you have to add back the 2 hours, and the total time taken will be 5 hours. Triangle QRT is drawn on a square grid using lines PQ and QR. Draw a parallelogram PQRS. I suppose line P is already drawn because P looks like it's already printed. So PQ should have been there. I don't have a ruler. I mean, I can't use a ruler right now, but y'all, please use a ruler. Okay, so PQ is supposed to be printed already. Now, how do we draw the parallelogram? Now, parallelogram means that you have two pairs of equal lines and also two pairs of parallel lines, right? So how do you draw parallel lines? Using the grid, you don't, it's not like an estimation, but rather you should use a grid. Okay, so QR has to be the same as PS, right? And you need to have an idea of what the parallelogram looks like. So QR is the same as PS. How you move from Q to R will be how you move from P to S. Okay, how are you going to move from Q to R? So you are cutting across how many squares? When I say cut across, I mean like from one corner of a square until it sits nicely in the corner of the other square. So Q is here, and it's cutting across all these squares until it sits nicely in a corner for point Y. So it's cutting across 4 squares horizontally. So I'll do the same for P. 4 squares away is over here. So cut from one corner all the way to this corner. Okay, so this is point S. Next, connect. Or you can do this. Let me show you in another color. Go to the right 4 times. Come down 1 time. Go to the right 4 times. Come down 1 time. Follow the same sequence, and that line will be parallel and equal. Same for PQ. If you were to draw RS following QP, right? From Q is one, two, three, four. 4 to the left and 3 down. So R will be 4 to the left and 3 down. You'll end up at the same point. Okay, so this is how you draw parallel lines. Oh, for part B, what fraction of the area of this parallelogram is the area triangle QRT? Okay, so QRT, what is the area of QRT? The base is 4 units. Triangle, the triangle, the base is 4 units. And the height is 4 units. Okay, maybe just highlight. Oh. This is the base. And this is the height. Base is 4 units, height is 4 units. So half times 4 times 4 for the triangle. Then the parallelogram The parallelogram can be split into two triangles. Which is PQS. So if I were to look at PQS, right, the base is here, the height is here. And the parallelogram is twice of that. The base is 4, height is 4. So for the parallelogram is 2 times of the triangle half times 4 times 4. So can you see half times 4 times 4 is the same as a triangle, but the parallelogram has 2 of that to form the area. So what fraction of the parallelogram is the triangle? Triangle is half of the parallelogram, so half. "25, the graph shows the number of pages printed by a printer over 7 minutes. At this rate, how many pages will the printer print in 20 minutes? So let's find out what's the rate. Every 2 minutes, 1 minute a bit hard to read, but every 2 minutes, you can get 25 pages. So 2 minutes, 25 pages. What about 20 minutes? Times 10. So 250 pages. 26. The difference between two whole numbers is 45. One of them is a 2-digit number and the other is a 3-digit number. What is the smallest possible sum of the two numbers? Okay, so 3-digit minus 2-digit. Difference 45. What is the smallest possible sum? If you want a smallest possible sum, then you want the smallest possible numbers that can be formed with this 3-digit and this 2-digit number, right? So the smallest 3-digit number is 100. So if this is 100, what is the other number? So 100 minus 45, which is 55. So this is 55. But we're looking for the sum. So 100 plus 55. Question 27. Draw the top view. Now take note, if you're drawing the top view, right, imagine you are standing here where the front view is, you're standing from the front and you're looking down. And okay, the thing is for this question, right, you can see most of the cubes, but you can't really tell if just to like confirm if there's another cube behind, because it is right next to this cube, but you can't tell if it's an empty space or not. So you have to read the question. If they say 8 unit cubes, right, then you count. Are 8 unit cubes visible to you, or is there another one hidden behind? So 1, 2, 3, 4, 5, 6, 7, 8. There's nothing behind, right behind this one, right next to this. Okay, you get what I mean now. Maybe I'll just highlight which one I'm talking about. So from the top view, got this. Okay, this is from the top view. So these two first. Then this one above the second one. Then there's one next to it. And there's one here. So this is what it looks like from the top view. Now B, find the greatest number of unit cubes John can add without changing the front and side view. Without changing the front and side view. Now the front view, what does it look like? Use this. So the yellow one represents the front view. Okay, where else can we add so that the front view and side view doesn't change? Let's highlight the side view. You just focus the one in yellow and pink. The side view, front view is like a U shape, right? And the side view is just 6 blocks. Right, the front is like that. Then from the side, it's like that. We can add here 1, 2. Oh, okay, maybe we go by layers. The bottommost layers, right? You can actually fill up everything. It's not going to change. So there's 1, 2, 3, and 4. So bottom layer 4. Again, where's the 4? Here 1. Then there's 2, and then there's one more space behind this, not visible from here. So 1, 2, 3, 4. Now second layer, how many can we have? You can have one above this one, okay, right next to this one. Then the middle row, you cannot fill up anything because it will block the front view already. But behind, you can put 2 more. You can stack 2 more. So one in this row, and then the last row we have 2 more for a second layer. So second layer 3, total you can add 7. All right, next question 28. Cheryl had 3 more 50-cent coins than $1 coins at first. She paid $2.50 for a pen using 3 coins. So state whether it's true, false, or not possible to tell. Okay, so first, 3 more 50-cent coins than $1 coin. Total she paid $2.50. Okay, so the total value of $1 coins was more than the total value of the 50-cent coins at first. Is it true? $2.50 can be three coins. The only way will be 1, 50 cents. If we look at the $1 coin, right, she needs to have at least 2 because that's the only way to pay for the pen, right? So she needs to have at least 2. So what if she only has 2 $1 coin? Let's see if the total value of the $1 coin will be more. So 2 $1 coin, assuming she only has 2 $1 coin, $2. Then she has 3 more 50-cent coins. So that's 5 50-cent coins. This will give us $2.50. Right? So which one is more? The 50-cent coin value will be greater than this. So it could be false. But if let's say we increase the $1 coin, so I'm basically trying to find scenarios where I'm proving whether it's true or false, right? So if there's extra one more $1 coin, right? I will get $3 and 3 more 50-cent coins, which means 6 50 cents. This will be $3. So is it true that the $1 coin is more? Also not necessarily true because they could be equal. But if you do anything more, right, the $1 coin's value will be greater than the 50-cent coin already. So example, let me show you for $1 coin, then 50-cent coin must have 3 more, right? So 7 50-cent coin. This will be $4 and this will be $3.50. So in this case, the $1 coin is greater than the value of the 50-cent coins. So not possible to tell. There are scenarios that shows otherwise. This one, 50 cents more. This one, total value for both same. This one, total value for $1 coin greater. So not possible to tell. How about for B? Cheryl had 4 more 50-cent coins than $1 coin after paying for the pen. So if there is okay, let's draw a model. 50-cent coins versus a $1 coin. She had 3 more. So we're not exactly finding out like how many coins she has, but we're just focusing on the difference. Okay, initially there's extra 3, right? We're talking about quantity only, number of coins. And this 250 is definitely 2 $1 coin and 1 50-cent coin. So if I were to remove 2 $1 coin and 1 50-cent coin, 1. What will the difference be? The difference will be from here all the way to here. Okay, difference. And how much is this difference? This difference is actually, because this is 2, right? 3 minus 1 is 2. So this is actually 4. Is it true that she has 4 more 50-cent coins? Yes, it's true. Okay, now let's look at 29. Batteries were sold in packs of 9 batteries or 5 batteries. Adam bought 12 packs with a total of 88 batteries. How many packs of 5 batteries did Adam buy? Okay, this is your assumption or supposition. So assume all or suppose all are packs of. Now, if the question is asking for 5 packs of 5, then we start off with the opposite. Okay, packs of 9. Total number of batteries will be 9 times, there are 12 packs, so 9 times 12. Remember, it's not 9 times 88, it's 9 times 12 because 12 is the number of packets. You have a total of 108, but actually the total is not 108, right? The total is only 88. So the extra that I need to remove will be 108 minus 88. We have extra 20 batteries, which means that not all of them are packs of 9. Some of them has to be packs of 5. So we have to like exchange. Every one exchange. From a pack of 9 to a pack of 5, I will lose 4. Okay, that's the difference between one pack of 9 and one pack of 5. I lose 4 every exchange. Now, because I need to remove this extra 20 batteries, how many times do I need to exchange? So I'll take 20 divide by 4. This is the number of times I exchange, and this is also the number of times I'm bringing in the packs of 5. So how many times? 5 times, so 5 packs of 5 batteries. Okay, let's look at next question. This one is quite challenging. So Mr. Lim packed 284 eggs on large trays and small trays to sell. He filled each large tray with 8, each small with 5. All the trays were full and there was no egg left over. What was the least total number of trays used by Mr. Lim? So we need to find a combination that can fit all the eggs exactly. And we are looking at not any number of trays, but the least number of trays that's used. So if they're saying that least number of trays, right, of course, you want to put as many eggs as possible on each tray. So first we start off with what is the highest number of large trays we can go. Okay, so 284. If you were to pack everything onto large trays, so you divide by 8. If you do your long division, you'll get 35, remainder 4. Now this remainder is important because whatever that is in the remainder that is not on the large trays will go onto the small tray. However, remember there's no leftover. It has to fit nicely. If you have a remainder of 4, it's not going to fit nicely onto a small tray. Okay, so what is the number of what is the number in the remainder that we need? It has to be a multiple of 5. So 35 large means that we have remainder of 4 remaining. Now, if 4 remaining is not what we want, we're going to remove 1 large. So when you have 34 large, then you'll have 4 plus 8. Because 1 large is 8, right? So basically you're taking away 1 large tray away and then you have 8 more eggs. So this is a 12. 12 remaining. So remainder has to be a multiple of 5. So this one, no. This one, no. Keep going. So 33 large. We're going to add another 8 from the large. You get 20. 20 remaining. So yes, this is what we want. 20 remaining is a multiple of 5. So how many number of small trays? Twenty divided by 5. 4. So 4 plus the 33 large trays, total 37. Okay, so this is the least number of trays that we can have in order to fit all the eggs. Okay, with that, that's the end for paper 1. This is Catholic 2023 prelim paper.